Hello dear students, here we'll go for the introduction of power electronic devices, that is power transistors, IGBT, SCRs, tracts, LASCR, LASCS and so many power devices. I myself, Professor M.N. Zadav, faculty in electronics from KK Polytechnic. Now, in today's session, we will go the basic introduction, what is power electronics. It is nothing but one of the branch of the electronics, and in power electronics it is the study of switching electronic circuits in order to control the flow of electrical energy. This power electronics technology behind the switching power supplies, power converters, power inverters, motor drives and motor starters are there. Now, here we'll again study what is the role of power electronics in the area of our working field. The power electronics is a new kind of industrial revolutions because of its important role in energy conservation, renewable energy systems, bulk utility energy storage, and electrical and hybrid vehicle, which is today's important priority. In addition to this, we have also some traditional roles in industrial automations and high efficiency energy systems. Here, there's a pictures of some basic power devices. Firstly, we'll see what are the types of interfaces. The types of interfaces are DC to DC converters. It may be chopper, AC to DC converters, that are the rectifiers, DC to AC converters, that are the inverters, and AC to AC converters. Those are nothing but the cycloconverters, in which there is a change in frequency of the supply. Also, we observe here some power components such as just I told you, diodes, MOSFETs, IGBT and SCRs. And for the same, the energy storage elements are inductors, capacitors. Here we'll go what is the basic of power transistors and a little bit introduction of power transistor. Just like normal semiconductor diode, power transistor is there, which have three terminals: emitter, base and collector. With a little bit difference between our normal transistors and the power transistor is that only the power transistor is physically larger than our normal transistors, and these power transistors are capable of carrying more current without melting or without burning up. Just for the sake of precautions, we have to use the heat sinks for its operations or in the circuits for power transistors. Here the symbol of power transistor. There are basically two types, PNP and NPN type transistors with the three terminals: emitter, base and collectors. Here the construction or the structure of power transistor is there. It is just like your normal transistor, but the N layer is added in the power bipolar junction transistor, which is called as the drift region. In power transistor, it has four structure alternating P and N type doping material as shown in the diagram. Basically, the power transistors mostly used are NPN type other than your PNP transistor types. And the characteristics of all these power transistors, they are dependent on the doping level of each layer. That may be the number of molecules, the components added such as electrons and the holes. Also, the important point is that the thickness of the drift region determines the breakdown voltage of the power transistors. Now we'll see what are the characteristics of power transistors. The characteristics of power transistors are plotted with respect to collector current and collector to emitter voltage. Here, the structure is shown for the plotting. For each readings, we have to make the changes in the emitter base current for the transistors. So this figure shows the VI characteristics of power transistors having different regions such as head saturations, quasi-saturations, cutoff region and active region. Now we'll see the points in detail. What is cut-off region? The descriptions is specified here. What is active region? Basically, in this region, the BJT is used as amplifier, and in this region, the power dissipation is maximum. The difference between the characteristics of normal transistor and power transistor is quasi-saturation region. This region is between the hard saturations and the active region, just we observe in the waveforms. In this, the power losses are less, and in this region, the device does not go into deep saturations. It can turn off quickly when the switching time for the operation is high. The fourth point for saturation is hard saturation region. This region is also known as the deep saturation regions. The resistance offered in this region is minimum, so that more amplification is possible with the help of these transistors. Now here the advantages of power transistors are there. First point, we will see the voltage gain is high, the density of current is high, the forward voltage is also low, and the gain of the bandwidth is large. But also we have the disadvantages of some power transistors. Its thermal stability is low, it is noisier, and controlling of this power transistor is little bit complex. For its operations, we have to take the care to use of heat sinks. And the applications of power transistor, it is basically everywhere it is used. It is used in switching mode power supply, relays and drives, power amplifiers, DC to AC converters, power control circuits, AC motor speed controllers, and so many. Thank you.